Hello, I'm Christos. Maybe some of you know me at this point because I come to every single conference. And today I'm going to be talking about sound on FreeBSD, how it works, how we do sound on FreeBSD. Even though the title says Sound 4, which is a basic kernel module, I'm going to give a brief overview of mostly everything, but with a focus on the actual Sound 4 kernel module. So yeah, even George Orwell used it, by the way. That's a real picture. So who are... okay, so something is wrong with the PDF. So who am I? I'm a FreeBSD committer since some year, I don't know, 2023. Yeah, I currently contract for the foundation to work on audio. Maybe I shouldn't do that because I keep producing too many bugs while fixing some. And so, yeah, let's start. So the talk is going to go, as I said, how does sound travel from application to your ears? The sound, well, here, the sound card, but it's eventually your ears. And vice versa. How can you record sound and take it from the microphone to the application? And so we're going to cover the various layers we have, except the hardware ones. Userland, Sound 4, again, the main sound code, and then the device drivers. We're going to discuss some improvements, just mention them. And if I have time, I will just spend a minute talking about why you might want to use FreeBSD for music, even though probably none of you has thought about this before, maybe one or two. So this is the, let's say, very high-level control flow of how sound works. If you notice, the arrows are not all the same. Some arrows send data to the device, eventually speakers. Some others take data from the sound card and go up to the process. So playback, recording. And some processes can do both. For example, you can record sound and play sound, like Firefox or whatever. So this is the userland part, the one that is highlighted in blue. We have the processes. This could be MPV, Firefox, OBS, and processes interact with the character devices, dev DSP. I guess you've seen them. So let's see how this works. Okay. Let me just continue with the control flow. So we have Sound 4. So the devices talk to Sound 4. Sound 4 talks with the device driver. The driver talks with the sound card, and then the peripherals. So userland, okay. So userland, how it works is really simple. You just use basic syscalls, open, close, read, which interact with, so the userland interacts with the open sound system, OSS. It's a kind of old API, but it's stable, it works. It has some problems, but if you compare it to ALSA or the Windows API, you'll see that it's really, really more elegant. So these are all the possible syscalls a user program can use to interact with the sound. You have open, close, well, open and close the device. Read, write for recording and playing audio. I/O control, you can change sample rates, ask the name of the sound card, change format, do volume control, buffer sizes. Then we have select and poll, just in non-blocking mode. When the device is ready to receive or send data, you get an event. And mmap is quite interesting. It's actively discouraged by the official developers of OSS, and also by me. People use it because you get direct I/O, somewhat direct I/O with the sound card, and supposedly you get better, lower latencies, but it's so complicated to do it correctly that most likely you're going to make bugs and not sound come out of your speaker. So there are applications that use it, maybe high-end scientific applications or some games might want to use this, but with these you are absolutely fine. So for anyone interested, I can share the slides after. This is the most basic program you can write with OSS. This is just takes audio from your microphone and plays it back to the speaker. So you open the device. So dev DSP is the default device. It's not really anything crazy. You just open the device with read-write. You set the hardware channels that you want to sample from. So let's say I have a sound card there in my bag that has 2 hardware channels for sampling, so stereo. But here we choose mono. Then you choose the sample format, 16-bit lower endian. Then you choose the sample rate, that's a classic one. And then you just, in a for loop, you read one sample from your microphone, you play it back to the speakers, and then you close the device. That's it. So very simple. You shouldn't write applications like this, but just to showcase how you can get started just with, how many is it, 10 lines of code. So now we'll move on to the more interesting stuff, the main kernel code, which does. So you might have seen it mentioned as PCM. That's mostly for historical reasons and also because the directory that the code is stored is called PCM. So this is just a generic layer for drivers, device drivers to attach to. So we have many drivers, USB sound cards for HDA sound cards, for other PCI sound cards, and all these attach to this layer so that we can have a nice unified interface. You access the same /dev/DSP device for any sound card. You don't really need to care what sound card it is. You just access it and it works. It also implements the OSS API. As I said, exposes the devices. We also have the mixer device. I'm going to talk a bit about it. It's not really interesting. It does channel and buffers handling. It has a processing chain, which is probably the most interesting part. I will talk about it. Sorry, I'm getting ahead of myself. It also has some sys controls. These ones, the hardware.sound, are just global sys controls that affect the whole sound system. And then you have the dev PCM ones that are separate for each device. And you can set sample rates there. You can see various properties, names, sample rates, equalizer, whatever. And then you have this third device, which just shows information about the current, all the sound cards, their channels, everything. So this is how the DSP thing works. So when you access one of these devices, these are your processes, you access the device, and then with using the CDEV-Priv framework, we can just assign channels to each device. So this one will go to proc 0, this one will to proc 1, this to proc 2. So when you have multiple processes that are accessing one device, you need to know which sample goes to which process. You cannot just dump all the sound to one process, or you need to somehow separate processes and work in a more organized way. So all those private structures, they have up to 2 channels. You can have, as you can see, you can either have one recording channel. So if you're just recording, you'll be assigned one recording channel. If you do both, you'll be assigned one recording, one playback. And if you're just doing playback, you'll have, one playback channel. So these are virtual channels, as you can see, which means we have virtual channels so that we can have up to infinite processes that can access the device at the same time. Because the sound card usually has 2 channels, right? Let's say. And it's not possible to access one channel, let's say the playback channel, with 100 processes at the same time. So we have an upper layer with virtual channels, and then we do the whole mixing, post-processing, and then we send it to the actual hardware to be played back. So Dev Mixer, I said it's not really interesting. It's used just for volume unmuting and muting. And recording source setting, it's not really needed anymore. It's just mostly a legacy feature. Even the manual says you could just not use it. But Mixer still uses it. So it's not worth to rewrite something that will eventually give us the same outcome. But it is there. You can use it. So we have the SND stat. This is, as I said again, just prints information about devices. You can use the cat command on this device, and it will print out device names, what channels they have, what processes use them, and flags. And I would say, since there is this utility since 14.3 stable and current, you can just use this, and it uses all the information from SND-stat through the NVList interface it has. So you don't really need to access this anymore, I would say. You can just use this, and you'll be fine. Also, virtual-SS and some other applications use those. So channels. So I mentioned before channels, virtual channels. What is all that even? So a channel is really just an organized way to receive and send, and to record and play audio. That's all. You have a buffer, you do stuff with this buffer, and you either send it back to the user LAN or you send it to the sound card. Really, that's it. Don't think of channels as in the actual hardware channels in the sound card. That's a different thing. So each channel has two buffers. One buffer that is, we call it software buffer in some places in the code, because it just interacts with mostly the Sound 4 and user LAN. So if you write bytes to a buffer, you'll actually write here to this one. So we call it software buffer. Well, then at some point, this buffer is copied to the hardware buffer. After all the processing is done, we copy the secondary buffer to the primary one, and then we send sound to the driver, or we take sound from the driver. And now we have the processing chain. As I said, that's maybe the most interesting or more involved part of the whole thing. So processing chain means we can, in the kernel, we do sample rate and sample format conversions. So let's say you play an MP3 file, but the application converts this MP3 file to 16-bit format. But your sound card actually works with 32-bit format. Well, you cannot just send 16-bit PCM streams and expect your card to play. You'll not get the right result. So Sound 4 is responsible for taking any formats and converting them to what the card actually needs to receive. And also it does the same for rate. So we can do resampling. Let's say you give it 40,400, 14,000, oh Jesus, 14, what is the number even? 4? Yes, this, thank you. So you can convert this to, let's say, 96,000. If the card expects this format, you cannot just send it whatever. Yeah, so we do the conversions. We also do equalizer. It's quite hard to use right now, so it's there, but I would say, yeah, you need to know how to use it. We also do mixing, because we have many virtual channels, as I said, and each process writes its own sound. We need to combine all this to a single stream so that it's played by the card and you hear all the sounds at the same time. Otherwise, you would hear separate samples. So you need to combine all the samples, mix them together, and then it's ready to go to the sound card. We also do channel matrixing. This is, maybe some of you, more the audio people, may have seen, for example, you might have a setup in your house that is called like 5.1 channel sound. So if you remember from the previous program, the sample program I had, I used mono sound, or you could use stereo, let's say. But if your card actually works with 5.1, well, you cannot just send it stereo format. You need to convert this to a 5.1 stream, and then it's ready to go to the sound card. And the opposite is true. If you're recording, but from a, let's say, stereo card, and you want mono stream, then you have to take this stream, convert it to mono, and then it's ready to go to user land. And also volume control. I guess you all know what volume control is. So each channel has its own processing chain when it's created. It's not a global chain for everyone. So let's say that for one channel, we just need resampling. That's it. We don't need anything else. So this channel will just get the resampling part of the chain. Other channels may need matrixing, so they will get just the matrixing. Other mates needs all of that. So we give each channel their own processing chain, and this whole thing is triggered by the driver. It's not so. Let's say you have a USB card, and it reads it every few seconds, or when it's ready, it needs to take samples and play them to the speaker and send them to the world, to the speaker, right? Or you're recording, and when it's ready and it decides it wants to send those samples back to userland, then it will interrupt the channel with this function, and then the whole processing will happen. And if you want, you can use again this command to dump the processing chain. You just run it. It will show every channel that is active for this sound card, and it will print which parts of those chain you have. So is this understood even, or am I just rambling too much? So one thing that I think FreeBSD is very good at is low latencies. And this is why I'm going to talk later why you might prefer it for music production. So latency, I guess, does any of you not know what latency in sound is? Okay, so we all know what latency is. So if you want, so all this processing, virtual channels, it causes overhead, right? And because we deal with sound and so if you, let's say you're a musician and you're recording and you need to have as low latencies as possible because you're playing guitar and you want to hear at the same time, and you don't want to just hear what you're playing 1 second after, because that's unusable. You cannot play like this. So you might need to have as low latencies as possible. So to do that, you can just start disabling stuff from your sound system. You can disable vChannels, for example, virtual channels, sorry. You can run this command nowadays, and that will just disable the virtual channels, but this means that when you access a device, only one process can access the device each time. As I said, we have virtual channels so that we can have multiple processes accessing them at the same time. If you disable them, well, you just give access only to one application at a time. You can also skip processing. You might see it as bit perfect. I know some people who are audio people will say, no, this is not exactly correct. I know, but it's for simplicity's sake. You can disable processing by some of the processing by enabling the bit perfect option. But if you want just a shorthand, I just have made this nice shorthand command. You can it has same defaults for getting as real time as possible. And you can also use the latency syscontrol, but there are more syscontrols by Sound4. The drivers also have their own syscontrols. So yeah, if you want after the talk, we can just look at each one of those individually, because I will not have time to explain all of them. You can also use the Mac priority and real-time priority features to get even lower latencies. I just give, let's say, your audio recording program real-time priority, but this will obviously cause CPU problems. You'll have more CPU wake-ups, hence more load on your computer, but you'll have lower latencies. So Florian Valpan actually has written a nice has some nice notes on using low latencies with Jack. I don't know if any of you has produced music. Probably you've used Jack. It's just an audio server that gives you low latencies. It's used by recording programs mostly. So yeah, you can go here and see what he has to say. It's really mostly this stuff, but in a more explained way. So drivers, now we go one step down the control flow. Well, drivers are, well, hardware drivers. They talk to the hardware. So let's say you have, okay, I have a sound card here. That's just a USB card. You connect it, so it attaches to this driver, the U audio driver, right? If you had some of you, well, most of you, who have laptops have integrated sound cards, so they attach to the HDA driver. It's like network interfaces. You have drivers for network interfaces. It's the same thing for audio cards. And yeah, so the drivers do communicate with the sound card. They do all the internal things, PCI, USB, yeah, all the stuff that drivers do. And they also talk with Sound4 to interrupt channels, to set up buffers, inform Sound4 about what sample rates are supported, what formats are supported. And there's also a new testing driver. So this doesn't play sound, it's just used in the test suite. You can use it for testing patches. And each of those drivers, as I said earlier, they implement their own syscontrols. So USB driver has this syscontrols, HDA has this, and a few more. So again, after the talk, we can go through all these if you want, but there are too many to list now and explain. But this is just a rough overview. Sound driver talks with the hardware, talks with Sound 4. It's just an intermediate layer between hardware and the kernel, and then the user land. So how does someone write a device driver? Let's say you have a brand new card that you need to support. How do you support it? So first of all, you have to initialize, as with every driver, you initialize the internal resources. If it's a USB, you'll do the PCI setup, you DMA, you'll set up any callouts you might want. Just normal driver initialization. Then you have to implement two interfaces that are provided by Sound, the Sound 4 module. I didn't explain them intentionally because I don't think there's really any reason. It's just, let's say, the communicating, one of the ways that Sound 4 communicates information with the driver. Again, after the talk, we can see those, what they do exactly. But think of it just a communication layer, a generic communication layer. So then you have to create a primary, as in hardware channels. If you remember, I showed here a bunch of stuff. So, yes, you can.
I'm getting a little bit confused.
I know.
I have background in audio. When you talk about channel, are you talking about a stream, or is it one channel, which can be like in a mixing board, there's one channel, one mic. So there's no question of a channel being mono or stereo. The stereo consists of two channels.
Yes. So I think I explained this before. So these channels that I'm talking about are not to be confused with the channels your sound card uses. So if your sound card has its own, let's say, 5.1 channels, right? That's in the sound card. But when I refer to channels, I refer to just the stream, yes. Okay. And then we do...
There's a terminology thing even in the naming, because a channel is very specific in audio.
Yeah.
It means mono.
So it does function like an actual channel. Like you just give it audio, it does the processing and everything. But it's just the software part of it. It's not...
And just another point, when you talk about channel matrix, that again has a very specific...
This is exactly what it means.
Implication, which is not surround sound. Channel matrix means multi-source, multi-output. That's what a channel matrix is.
I know, I just gave it as an example, like that we convert streams to stereo to 5.1 using this matrixing.
No, that's why I'm saying is that's not what a channel matrix is. A channel matrix would be you have a turntable, an MP3 player, a VHS tape player, and you want to send it to your bathroom, your kitchen. That's a matrix.
Right.
It's not what...
So maybe there's a terminology problem because we call it matrix, channel matrixing inside. So I was saying, the driver creates the hardware channels. Again, the software streams for taking bytes from userland and bytes from userland to the kernel and to the sound card. So we create those channels, and these reflect, let's say, the hardware channels. Let's say if your device supports playback and recording, we'll make one playback channel, one recording channel. And so all the playback stream will go through here, and then to the sound card, and then the sound card will do its own thing and route it where it should be routed. So where are we? So we create the channels with this function. Then we register to Sound 4, just two functions. And we also create the mixer, and that's it. Well, then of course you have to implement. You have to implement those. You have to implement those interfaces, for example, the channels, how to set up buffers, how to destroy the buffers, keep track of the pointers. But that's not, I'm just giving a high-level overview here. But you can look at the code for the dummy driver to see just a bare-bones driver, how it should work. That's it. But it doesn't attach to any USB PCI, so yeah, you'll miss the actual USB parts, for example. But if you want to see just how can I get my driver to connect to Sound 4 and actually have bytes from userland to the kernel, you can just look at this and that's fine. So hardware, actually I'm not going to talk about hardware because this is not a hardware talk. So once all this is done, samples go to the sound card, and then microphone, as you said, speakers, turntables, mixers, all sorts of things. So there's no reason to talk about those, obviously. So some new improvements. Better laptop support, meaning you all know that some laptops, they have non-standard configurations, and you might plug your headphones and not get sound out of them. So I'm trying to work on this. So I get reports all the time, oh, this laptop doesn't work, oh, I bought this new laptop, I connected headphones, and it doesn't work again, I'm going to switch to Linux. Yes, yes. That's actually very common theme every time. I know Alexander is here, and he's heard more complaints about laptops than me. And I have a patch that tries to address this issue in a more automatic way. I'm not going to discuss it right now. You can go to the review and leave your opinion. So I've made also some new tools. S&D control, I already showed examples before. If you use S&D stat, the character device, it's this, but in a more easy way to use. Plus, you can also configure things. So it's a combination, let's say, with the sys controls and the sound card and the sound stat device. So you can say sample rates, you can set sample rates, formats, see how many channels you have, see what device is connected, feeder, processing chains, all that stuff, just in an easier way. Also, MIDI dump, that's a bit unrelated, but it's also sound related, I guess. It's just a utility that you can connect your MIDI to, and you run it, and it just outputs whatever you press on your MIDI controller. I just made it to confirm that MIDI works. Like, does the driver, for example, recognize the notes correctly? Does it recognize velocity correctly? So you can connect it, run MIDI dump, give it the character device for your MIDI, and just press notes, and it will show which note you pressed, velocity, and everything. Also, hot unplug is supported. I know for many years, people complain that I have a USB card and I cannot turn off my computer, or my USB bus just hangs because I play sound and I try to disconnect my card. Now this works. So if you have a USB card and you just unplug it, it will work fine, no problems. Bug fixes and new bugs, of course. Cleanups, refactors, lots of them, which is the reason why there are so many new bugs sometimes. Tests, I've written some tests for the test suite. The kernel module had no tests before. I've written some simple ones for now. Also, floating point format support is now possible. I know the wine port, for example, could not work. Some parts of it could not work because we didn't have floating point support in the sound. Now we have, but it's really we just take floats. Let's say if you want to play floating format to your sound card, sound just takes the floating point samples and converts them to 32 signed samples. That's it. And it does the opposite if you want to record float. So you don't really record float. It's like a translation layer. Yes. Maybe in the future we'll have actual floating point support, like send actual floating point samples to the sound card. But I don't think, does any of you use a card that actually works with floating points? And not, no, I mean, internally works with floating points. Yes? Okay, so maybe we'll look.
Not on FreeBSD, unfortunately.
Yeah, see, so I'm gonna switch to Linux as well. So we could look into implementing support, actual proper float support. For now, I just implemented a very bare bones one so that ports can work. Also, since Hans Peter is no longer with us, I took over development of his program Virtual OSS and more stuff that I don't think is really notable. So I said if I have time, do I have time? Okay. So, FreeBSD for music. Why would anyone want to do this even? I mean, supposing you produce music, why would you do this on FreeBSD? Yes, he has turntables and runs FreeBSD. And so I would say the best reason you would do this for is because our sound system is just very fast and solid, and also very, you can configure it a lot. As I said, you can disable virtual channels and you get even lower latency. It's easy to work with, I think. Maybe it's a bit cryptic yet because of lack of utilities. So maybe to a user who just came to FreeBSD, it's not so obvious how do I do all this stuff. But I think with time it could be a very good option for sound production. And also, we have lots of new ports for plugins. LV2 is just, if you do music on Windows, you've heard of VSTs, for example. Yeah, LV2 is the open source equivalent of that. So there is a guy, I don't remember his name, but he's churning out new ports all the time with LV2 plugins. We can even do, if you play guitar, we can even do neural modeling. Does any of you know what this is or doesn't know what this is? Yeah, okay, so for guitar, even for a guitar player like me, it's great. I can already do most of the things I would like to do. I know if you make very complicated music, maybe it still lacks many of the features, but I think even if you use VSTs and you really need to use your Windows VSTs, I think there is a way to use VSTs on Linux and in general, convert VSTs to LV2. I think there is a possibility to do that. So I would say try it out. If you produce sound, music, you do podcasts, whatever, try FreeBSD. Maybe it's good. So do I even have next slides? I would like to thank Ed for usually the laptop parts. He's very helpful. Florian, he's not here, but he's a maintainer of Ardour port and Jack. He's very solid on sound. Goran Mekic is actually the one who inspired me to work on this. And he's also a FreeBSD musician, does metal, even goes to concerts and has a rack that uses FreeBSD live. So it's a very interesting. And that's it. Thank you. I hope I didn't confuse you all. Yes. I'll wait for the microphone. Yes.
This is great, Christos. It's my first exposure, but I'm going to ask you to just rewind a little bit. You put some emphasis on latency. The other half of it, so latency is like translation. You say something and it delays. But the other half is jitter, which is like a heart arrhythmia.
Yes.
Where it's inconsistent. So is that part of this work, or is there acknowledgement? Just the other part is you talked about test suites, and that may be something. Testing latency and jitter might be a worthwhile thing in the test.
So, yes, jitter, I think we do some. I'm not sure, so I might be wrong on this. I think we do some, corrections and stuff, but I think that's mostly the userlands thing to do. Am I right? Alexander, do you think that's the case?
Jitter is mostly hardware thing.
Well,
Jitter, in this case, more depends on hardware. Since all the sound system, as was mentioned, plays in context of or synchronized by the sound card interrupts. When you are playing back something, sound card generates interrupts according to the rate of data it receives. So all the conversions done by kernel, they are practically synchronized by the hardware driver. I guess there could be some artifacts if you try to play from different sound devices with different synchronization rhythms, which are not synchronous, but those very special cases, I guess.
Would it not be related to the driver itself, or if you're doing all of this virtualized process? A long time ago, a sound engineer told me, remember that sound is analog. We can play all we want in the digital world. What our ear hears is analog. So that's your ultimate standard. So everything that degrades along that path, along the digital path, is worthy of concern for fidelity.
So yes, sound does take care of this to some extent, but it's also the applications I need. For example, if you use a sound server, it will take care of it. Okay. But it's also hardware, as Alexander said. So the other question was, sorry, there was one more question you
Just
asked.
to add, there could be different implementation. For example, would we generate sound out of nothing based on sound on some third-party timer interrupts? There could be some fluctuation based on scheduling and everything. But here we practically have playback device which generates our fixed rate of 44,100 samples divided by rate divided by buffer size, which means we receive interrupt with fixed rate from hardware. And the only thing that we can do about is that can be counted as kind of jitter, but it has different, much worse effect, is that if we try to go for such a low latency that kernel cannot keep up, system cannot keep up with interrupt rate, and then we start skipping samples, not even samples, but skipping buffers. And it's much worse than jitter when it slightly fluctuates frequency, but we completely lost buffers and sound turns into garbage. So it's a question of latency, it's a question of sufficient buffering. We can shrink them as much as we can based on real-time priority, based on software optimizations and other things. But at some point, we just increase chance to lose, interrupt, and mess up everything. It should be just careful balance between those two. As soon as we keep within a range, all the jitter after that is question of hardware, how well it's synchronized.
Exactly, yeah.
And maybe just your test suite can
The test suite.
think about adding some of these, how much of that degradation is happening in the process.
Yeah. Yeah, it's still quite bare bones. So the test suite. It's just there to serve as a framework. If you want to write tests, you can follow. Yeah, so you had a question, I think.
Yeah, of late, hardware that I've come into possession with is at 48,000, and it's USB, and it's detected as hardware, and it even detects the 48,000, but the sound that comes out of it is like random, garbled, not even just sped up or anything.
So it could be that your settings. So as I said, you can set what the sound module will resample to. So if your card needs, let's say, 48,000, as you said, but you chose to resample at 44,000, maybe then there's a problem. Like maybe it's a problem with configuration. It's not really a problem with a card.
Well, in this case, for instance, it's a headset. You kind of expect it just to work, type of thing.
Yeah, I don't know. We'll have to look into this. I cannot debug it right now. So other questions?
Yeah, so maybe similar question. What's kind of the hardware that you can expect to work out of the box? What's the hardware support?
Well, all of them.
All of them?
I mean, USB works. I know you said you have a problem, but usually works fine.
Okay.
So the main cards that people use are PCI and USB ones. PCI usually being the internal one. It works, but sometimes you need to do some. I think at this point probably we've covered most of the laptops that need manual configuration. So I guess everything should work fine. I guess.
So if you plug like, I don't know, like a Focusrite or something like that.
I have a
you should
Focusrite there.
Should just expect it to work. Okay.
It works.
That's cool.
It works fine. Yeah, it
Nice.
works.
Pretty much any USB class compliant you can expect to work.
I find the USB ones to be the most solid ones.
What about older things like FireWire? Because there's a lot of hardware out there that is really good in terms of like DSPs and like capability, but
So
the software has kind of like bit rotted in the world. It would be nice
So-
to save it.
I will say this, because I don't own any of these cards, I cannot really work on those drivers. However, I know we have many of them. There are many drivers that we have especially PCI ones, that work with all sorts of old cards and obscure hardware. So yes, I guess they should work, but I've never used them, so I cannot really give you any opinion on that. If someone else has used drivers other than the USB and the HDA one, maybe they can, answer this question. So any other? Yes?
So I have a USB device that works, and it seems to have different hardware profiles, and it seems to default to 2 channels in, 2 channels out, although it is capable of 14 in, 14 out.
Yeah.
And I wonder what's the mechanism to switch to one of these other profiles?
So you can use the virtual channel settings, like use the format and how many channels you want. Or even better, you can use virtual OSS, the sound server. And it does multiplexing. You can use as many channels. You can map them to however you want. It's a bit complicated to use right now. I think if any of you has used virtual OSS, it's a bit cryptic to use. But it is possible. So we can look into this if you want.
I'm not sure we're talking about the same thing, because when it's in default mode, I cannot request more than 2 by 2.
Yes, that's the default, stereo. But you said you also have 14 channels and you want to use those, right?
Yeah, but it's really, when you use USB conf,
Yes.
you see this different profile, but I don't think I can switch to it. I cannot just request playback with like 8 channels.
Yeah, that's what I said. You can use virtual OSS to do that. And also, yeah, you can use it, definitely. That's the reason it exists, I think. The initial reason Hans-Peter created it. So you can use devices with multiple channels and make them work properly. But I will have to look into this. I don't want to give a wrong reply and
I have
leave this reply
PCI conf
forever.
dumped right here. So
Yeah.
Anyway, thanks.
No problem. Ed?
There may be there may be some device-specific tool or utility or something to configure it. I mean, I have a 18-channel Behringer mixer that it has a web-based control you can do on it, and it has an option for 2 in, 2 out, or 18 to 18, and it's like it's completely out of the scope of the USB port. It's just you configure it. So I mean, depending on the specific device, there may be something similar.
Sure.
As a musician yourself, which DAW do you prefer to use on FreeBSD?
Ardour.
Excellent, cool.
That's it, period. That's it.
Well, instantaneous answer.
Yes. It's very good. I mean, I would say it's even better than most of the Windows ones. I don't know. I think it's quite good. Very powerful.
What's that name again?
Ardour. Ardour. Next, or that's it?
I think I have 2 questions.
Yes.
One on support. I know you said you haven't necessarily used it, but do you know if there exists drivers for AVB cards? AVB, which is audio over Ethernet.
No, it doesn't exist. I know for a fact it doesn't exist.
Okay.
But because I thought there was no demand for it. So is there demand for this?
Is there what, sorry?
Is there demand for this?
I would use it.
Okay, so I see 2 nodding heads. 3. Okay, so we can look into this then.
And the second question.
I actually have it in my to-do list. But it's just at the very bottom of it. So now we'll go up the stack.
Okay. The second question I had is I encountered on Mastodon a whole thread about doing audio on the Apple M-based laptops.
Yes.
And how to get good sound out of those laptops, you need to do a lot of actual processing. You can't just send out a raw stream, and you have to do a lot of processing. I'm not sure if it's just EQing or other kind of processing to actually drive the speakers properly to get good sound. Do we have any of that in this vicinity, or is that something that hasn't been thought about yet?
So unplugged from Mastodon that I have no idea this existed. But I saw Ed also did. Yes, it is an issue. So please let me know, or send me an email. Let me know. Send me the thread maybe, so that I can look into it, because I've never heard of it.
Sure.
Thank you.
AVB. It's part of 802.1.
So, any other questions? You have 3 seconds. No. No questions. So that's it. Thank you very much. I hope I didn't confuse you a lot.